Welcome to another video. So in this video we are going to look at this MIT integration B question of 2023 quarterfinals. So let's solve this integral. So we can start off by expanding the numerator. So this one, the numerator is going to be I is going to be the integral from 0 to 1 of x raised to the power 4 multiplied by, we can expand this one by foiling it. That's 1 minus 2x plus x squared all over 1 plus x squared dx, right? So this is the integral from 0 to 1 of x raised to the power 4. I can write this one as 1 plus x squared one side, and then minus 2x divided by 1 plus x squared dx. Cool. So I is going to be the integral from 0 to 1. I can now split this one into two different integrals. That is x raised to the power 4 multiplied by 1 plus x squared minus x raised to the power 4 times 2x, like this, all divided by 1 plus x squared dx. Okay, so we have the integral from 0 to 1 of x raised to the power 4 of 1 plus x squared all over 1 plus x squared dx minus the integral from 0 to 1 of x raised to the power 4 times 2x. There's a reason I'm writing that, all over 1 plus x squared dx. Okay, so this one, the first one, this one really cancel up with this, and I have I to be equal to the integral from 0 to 1 of x raised to the power 4 dx minus the integral from 0 to 1 of x raised to the power 4 times 2x dx all over 1 plus x squared, like this. So the first one is really trivial. That is 1 over 5x raised to the power 5, the integral from 0 to 1, minus the second one. I'll just write it as it is, and then I will simplify it later on. 2x all over 1 plus x squared dx. This one, plugging in 1 is going to be 1 over 5, and plugging in 0 is going to be 0. So minus this guy. So this is going to be the integral from 0 to 1 of x raised to the power 4 times 2x dx divided by 1 plus x squared. And now the second one, I'm going to do a u sub there. So we can let u to be equal to the denominator 1 plus x squared, right? So in that case, x squared is going to be u minus 1, and x raised to the power 4 is going to be u minus 1 squared. And then what about the change in limits? And here du is going to be 2x dx. So in place of 2x dx, I'm going to replace that with du. And the change in limits, when x is going to be 0, u is going to be 1 plus 0 squared, which is 1. When x is the upper limit 1, we have u to be equal to 1 plus 1 squared, which is 2. So the integral is going to be like this. So I is going to be 1/5 minus the integral from 1 to 2 now of x raised to the power 4. X raised to the power 4 is u minus 1 all squared, and 2x dx is du. That is from here. All over 1 plus x squared is u. So this is 1/5 minus the integral from 1 to 2 of foiling that on top is going to be u squared minus 2u plus 1 all over u, all this one du. And that is equals to 1/5 integral from 1 to 2 of u minus 2 plus 1 over u, all this one du. That is dividing each term by u, the denominator. So 1/5 minus, now integrating this one is 1 over u. I'm sorry. Integrating this one is 1 over 2 u squared minus 2u plus the ln of u. And we are integrating all of this from 1 to 2. Cool. So 1 over 5 minus, plug in 2, this is the upper limit. We have 2 squared over 2, which is 2 minus 2 times 2, which is 4, plus the ln of 2. This is the upper limit minus the lower limit. Plug in 1, that is going to give you 1/2. Here is going to give you 2. ln of 1 is going to be 0. So that is 1 over 5 minus this one gives you negative 2 plus ln of 2. And this one gives you 2 minus half. That is going to give you positive 3 over 2, right? And negative 2 plus positive 3 over 2 is what? So this one is going to be 1/5 plus 2 minus ln of 2 minus 3 over 2. That is opening with a negative. And what does that one simplify to? So 2 minus 3 over 2 is 1 over 2, right? So that is 1/5 plus 1/2 minus the ln of 2. And this one simplifies to 7 over 10 minus ln of 2. So this one is the value of our integral. So therefore, if we integrate from 0 to 1 of x raised to the power 4, 1 minus x all squared divided by 1 plus x squared dx, this one evaluates to 7 over 10 minus ln of 2. So this is the value of our beautiful integral. So if you find this helpful, make sure to give me a thumbs up and subscribe to my channel for more engaging content from Calculus Diaries. I thank you so much for watching this video, and I will see you in the next one. Bye bye.